Grip two metallic slabs and try to force them together. You'll encounter a ghostly, impenetrable wall that defies your strength. Rotate one piece, and suddenly they crash into each other with a violent metallic snap. It is a raw, physical interaction that feels almost sentient. A basic curiosity emerges, one that feels both ancient and obvious. Why? What exactly is filling that gap between your fingers? Seeking an explanation often feels like descending a staircase where the steps eventually vanish into thin air. You crave a foundation built on familiar logic, something anchored in the world you recognize. You might imagine microscopic springs or invisible tethers pulling the metal closer, but that is merely a linguistic mask. If we accept the tether theory, your natural follow-up is, what makes those tethers contract? To answer that, we would have to discuss atomic structures and their internal bonds, which are actually the exact electromagnetic interactions we set out to define. We would be spinning in intellectual circles, hiding one riddle behind another. True understanding isn't a clever trick, it is a descent into reality. The reality is that you are already deeply acquainted with the power behind magnetism. You engage with it every second of your existence. However, it has become such a mundane part of life that its sheer weirdness is now invisible. Lean your weight against a desktop. It feels solid and firm. You believe your skin is making physical contact with the wood, but that is a lie. Not truly. As your palm nears the surface, the swarm of electrons circling your skin's atoms encounters the swarm of electrons around the table's atoms. They push back against each other with immense intensity. That perception of hardness, the very sense of touch, is actually electromagnetism in motion. It is the identical fundamental force that operates the magnets you hold. The desk is just as miraculous as the lodestone. You have simply stopped noticing the magic. So why does a magnet seem so unique? Because it allows you to perceive this cosmic force across a distance, unmasked by the neutral state of ordinary objects. Most of the electromagnetic energy in our world is bottled up, perfectly neutralized. Every bit of matter contains positive protons and negative electrons. In almost every material, this electrical charge is perfectly countered. Positive cancels negative with surgical precision. The force exists, monstrously potent, yet it remains buried in plain sight. Reflect on its scale. The gravitational pull anchoring planets in their tracks is pathetically weak when measured against the electromagnetic force. The gap isn't a factor of 10 or a million. It is a staggering, nearly inconceivable disparity. We don't disintegrate or implode because every speck of positive charge is meticulously paired with a negative one. The universe's most energetic engine is idling silently in the background of your room. A magnet is a rare location where this equilibrium is manipulated to produce a focused external result. This occurs in specific metals like iron or nickel. Inside every individual atom, electrons possess spin, and this rotation generates a microscopic magnetic field. In most objects, these spins are disorganized, pointing in random directions, their signals canceling out into a magnetic void. But in a piece of iron, given the right circumstances, these tiny rotations can synchronize, trillions upon trillions of them, all facing the same direction. Imagine a stadium where every person is whispering different words. You hear nothing but a messy blur. Now imagine everyone shouting a single word in perfect rhythm. The sound travels for miles. The individual voices haven't increased in volume, but their coordination builds a power that reaches far beyond the source. That is the essence of ferromagnetism. The synchronized spins no longer negate each other. They amplify, merging into a unified field you can detect inches away. But this only explains where the field originates. What is the field made of? What truly carries the push or pull through that empty void?
At this point, our common sense fails us, and we must drop down to the lowest floor of physical reality that quantum physics provides. At this scale, the narrative is told not through tugging or pushing, but through a series of exchanges. The electrons within the aligned atoms of a magnet are perpetually throwing tiny bundles of momentum and energy at the surrounding world. These are not the photons of light your eyes perceive. They are virtual photons, ghostly messengers that exist only long enough to complete an interaction. An electron in one slab of metal ejects such a virtual particle. An electron in the other slab catches it. This trade of messenger particles constitutes the force itself. The resistance or attraction you sense is the collective impact of trillions of these hidden negotiations occurring every nanosecond in the gap between the objects. The stunning clarity of our current knowledge is that every electromagnetic event, every lightning bolt, every vivid color, every chemical link, every solid barrier, and every magnetic pull stems from only three basic maneuvers. A photon moves from point A to point B, an electron moves from point A to point B, and an electron either ejects or absorbs a photon. That is the entire fundamental rulebook. There are no concealed gears or hidden pulleys beneath the stage of reality. The intricate fabric of our physical experience is knitted entirely from these three strands. Our command of this isn't just a philosophy, it is mathematical and incredibly sharp. In 1873, James Clerk Maxwell wove electricity and magnetism into one gorgeous mathematical framework, proving they are two sides of the same coin, electromagnetism. This discovery illuminated the modern world. We realized that a moving electric field births a magnetic one, and a shifting magnetic field generates an electric one. Our entire civilization is a choreographed dance of moving charges and fields. This loop is why spinning a magnet near wire produces power, or why sending electricity through a motor creates motion. Our whole technological world, from the massive turbine to the smartphone in your palm, is built on this structured interplay of metal and field, guided by Maxwell's logic. Even further, quantum electrodynamics allows us to compute magnetic traits with nearly absurd precision. We can forecast magnetic properties of an electron so accurately that the math matches reality as closely as measuring the width of a continent and being off by less than a human hair. It stands as the most triumphant predictive system in human history, and it all traces back to the pull you feel between those magnets. Yet, despite this predictive strength, deep enigmas persist. There's a specific ratio, roughly 1/137, called the fine structure constant. This value dictates the intensity of the electromagnetic bond. It decides how tightly electrons cling to nuclei, how hard magnets pull, and the very laws of chemistry itself. We can calculate it perfectly, but we cannot explain its origin. We don't know why it is 1/137 rather than 1/50 or 1/100. If it shifted even slightly, atoms would fall apart, chemistry would vanish, and the cosmos would be barren. The very reality of your existence depends on this mysterious number. It is a quiet, fundamental setting of the universe, etched into the cosmic code for reasons we cannot yet grasp. This leads to the final, humbling realization about understanding these forces. Our minds evolved to handle medium-sized items moving at slow speeds. The quantum world, where particles act like waves, where reality is a game of chance, and where forces are particle swaps, is entirely alien to our natural instincts. We have no perfect mental image for an electron. It isn't a solid bead, or a wave, or a mist. It simply is what it is, and we use math to map its behavior. The math works with terrifying accuracy, but the math itself is the only true picture we have. We are like a brilliant, sightless mathematician who can predict exactly where a ball will land without ever knowing the color of the grass. So when you feel that magnetic resistance, what are you actually touching? You are touching a pillar of the universe. You are sensing the unified alignment of countless atomic spins. You are feeling the impact of virtual particles screaming across the void. It is the same energy that builds your skeleton, that triggers your thoughts, and that keeps the stars burning. Magnetism isn't a weird quirk to be explained by simpler things. It is the explanation for almost everything else. The magnet's true power is that it pulls back the curtain of reality. It takes the force operating inside the atomic clockwork of every sight and touch and makes it tangible for human hands. That push or pull is nature being remarkably honest, showing you what is always true everywhere. We lack a familiar analogy for it because it is the foundation upon which all our analogies are built. The secret isn't inside the magnet. The magnet is a window, and when you look through it, you witness the vibrant mathematical engine of the cosmos working silently in the space between your palms. Make sure to like and subscribe to Hard Science Theory if you want to see deeper into the clockwork of our world.
To grasp the magnitude of these unseen interactions, consider the sheer density of the events taking place. Within a single gram of magnetized iron, there are more individual electron alignments than there are stars in the observable galaxy. Each one is a contributor to the macroscopic force you feel against your palm. We often take for granted that the physical world remains cohesive, but without this specific electromagnetic tuning, the very concept of solid would vanish. Imagine if the electrons suddenly stopped repelling each other. Matter would simply collapse into a state of infinite density, and the structure of our bodies would dissolve into a chaotic soup of subatomic particles. This is why the study of magnetism is not just a study of metal, but a study of existence itself. The legacy of James Clerk Maxwell and the later pioneers of quantum electrodynamics, like Richard Feynman, provides us with more than just formulas. They provide a lens through which we can perceive the invisible. When we look at a magnet today, we aren't just looking at a tool for a refrigerator or a component in a hard drive. We are looking at the culmination of centuries of human inquiry. We are looking at the proof that the universe is governed by laws that are elegant, consistent, and profoundly mathematical. The fact that we can describe the dance of a photon with such precision is perhaps the greatest achievement of our species. It bridges the gap between our limited biological senses and the true underlying architecture of the cosmos. As we move forward into new frontiers of physics, exploring topological insulators, superconductors, and the potential for magnetic monopoles, we continue to build upon this foundational knowledge. Every step we take deeper into the quantum world reveals more about the electromagnetic force. We are learning how to manipulate these fields with increasing finesse, opening doors to quantum computing and advanced energy systems that were once the stuff of science fiction. Yet, no matter how advanced our technology becomes, the fundamental mystery remains. Why these rules? Why this specific constant? Perhaps one day we will find the answer buried even deeper in the mathematics, or perhaps we will find that some questions are simply the bedrock upon which all other answers must sit. Regardless of the answers yet to come, the experience of holding two magnets and feeling that invisible push remains one of the most direct ways to interact with the true nature of reality. It is a moment of pure, unadulterated science. It is an invitation to wonder, to ask the difficult questions, and to realize that the universe is far more complex and beautiful than we can ever fully imagine. The next time you feel that resistance, pause for a second. Think about the trillions of virtual photons, the perfectly balanced charges, and the ancient engine of the cosmos humming between your fingers. You are holding the secret of the universe in your hands. Thank you for exploring the depths of reality with Hard Science Theory. Keep questioning, keep observing, and never stop looking through the window of science to see the world as it truly is. Your support helps